Oakley dokley, folks. Now we're going to look at, in our installment 64, rolling right along, quadratic functions and domain and range. Let's see what we can do with this now. We're going to talk about finding the domain and range from the graph of a quadratic first, and then we're going to take a quadratic from its equation, so the standard form of the equation, figure out what the graph would look like, and then state the domain and range from there. Wow, that's a lot. Let's go. So domain and range from a graph. So this is a sort of hearkening back to your grade 10 knowledge base there. So important stuff. But in grade 10, we learned that if we have a graph, we can write its domain and range by looking at where the x values go and where the y values go. Okay? So for this first one, what we have to do to get the domain and range here is remember the domain is all the possible values I can have for x. So since this graph opens out to the left and out to the right forever, there's no limit to how far it can go, and it doesn't skip over any numbers. So we say that x can have any value at all. So we write the set of all values of x such that, x can be any real number. So that's x, that's a Greek letter epsilon, and that's a scripted r. So x can be any real number. Alternately, we could write that in interval notation, saying x is an element of an interval that starts at negative infinity and goes all the way up to positive infinity. Okay? Now, you'll notice that that'll be the same for both of these because all parabolas open up forever in both directions in the x direction. So I could write the same thing as the other one, as before. So the domain, as long as it's not a contextual problem where we have to impose some other kinds of restrictions, the domain is always the same. Let's look at the range now. Range is different because a parabola will either go all the way up forever, like the first one here, or it'll go all the way down forever. But at some point, it sort of gets cut off and has to stop at either a minimum value or a maximum value. So to write the range for that, what we'll do for the first one is we'll say all values of y that are real, except y has to be bigger than, can't be anything below, so it's got to be bigger than or equal to -3. And if I write that in interval notation, I just say y belongs to a set. The lowest it could get is -3, including that with a square bracket there. I shouldn't have this. I don't know where that came from. And it can go up as high as positive infinity without bound on the upper part. And the range for this other one over here, is going to be all values of x, all values of y, that are real. And in this case, we can't go above a y coordinate of 4. So we're just going to say that y has to be less than or equal to 4. All right? If we write that in interval notation, we would say y can be any number that starts at negative infinity. So we can go as low as we want on the graph, but we can't go any higher than 4, square bracket to include it. Okay, good stuff. Now, what happens if we want to start right from a graph, or right from an equation? Often you'll get a domain and range question, and it'll say, here's the equation, what's the domain, or what's the range? So let's see what we got. If we're going to draw a graph, first thing we want to get is a vertex. So let's get a vertex here. We should know that the vertex will be at x equals -b over 2a. So if we fill in that formula for this one, we're going to have the negative of -6 all over 2 times a, which is 1. So that's going to be 6 over 2, or 3 for the x coordinate. Then to get the y coordinate, I fill that x coordinate back into my equation. So I've got 3 squared minus 6 times 3 plus 7 already. So that's going to give me 9 minus 18 plus 7, which I think is about -2. So I've got a -2 for my y coordinate. So the vertex for this function is at 3 and -2. All right. Then I know it's going to open upward because of this. And if I want one more point to give me a good picture of what my graph looks like, grab C and tell the world that your y-intercept is going to be at 0 and 7. All right, so I'm going to say 10 units in any given direction should be enough for this graph. Okay, 1, 2, 3, 4 breaks there, 1, 2, 3, 4 breaks there. Just a rough sketch so that we can get our domain and range here. So we got 1, 2, 3, 4 going up to 5, 1, 2, 3, 4 more going to 10. So we'll say -5, and we're going to have -10. So we'll say 1, 2, 3, 4, blah, 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 doesn't really matter. And then we'll say -5 here and -10. And then we'll split that up. Remind myself next time to do this the other way, where I actually give you the picture. Okay, so let's draw a nice graph. So we got a vertex over 3 and down -2, it looks like. So I'm over at 3 and down to -2 right here for my vertex. The graph is going to open upward and has to go through a y-intercept all the way up at +7, so over here. Now, before I do that, I'm going to make sure I sketch my axis of symmetry on this thing. And the axis of symmetry should go directly through that vertex. And the reason I want to sketch the axis of symmetry first is because I know that all parabolas are symmetric. That's why we call it symmetry. So directly across from that point there, so another 3 units on this side be over at about 6, I should have another point that sort of coincides with it. So that gives me a nice, better picture of my graph. Whoops, missed. Not by much. And then on the other side, I'm going to go up this way and go right through that y-intercept. And that's roughly what my graph looks like. Now we can get our domain and range. Okay, so for domain and range for this guy, I'm going to say that the domain is the same as it always is, unless it's a contextual problem. All values of x that are real. That's the easy one for parabolas. Okay, and then the range will be all x values that'll go from negative infinity to infinity, not the range, just the other notation for your domain. All right, then we're going to state our range. Range in this case, also not too bad. As far down as that y coordinate there, which was at -2, so we're going to say y can be any real number, but it's got to be bigger than or equal to -2. So when I write that in interval notation, y is going to start at -2 and go all the way to infinity. Okay? So a quick summary here. A quadratic function, we get the axis of symmetry, coordinates of the vertex, find the y-intercept, and use symmetry to sketch the graph. Once we have that, domain is always the same. Y either starts at one point, k, and goes upward, or it goes from -infinity all the way up to k and stops. And that's it. Good luck.